In this second example for solving linear equations, what we want to notice here is to solve this equation, we're going to have to deal with some fractions, and there's one of two ways that we can do that. The best way, in my opinion, is to get rid of the fractions right out of the gate, but some people would say get a common denominator first. So I really want to illustrate two different thought processes here, which are ultimately the same working process. So getting a common denominator for dealing with fractions. Okay, so what you need to do first is look at all of your denominators, and if there is a term that doesn't have a denominator, put it over 1, but in this case our denominators are 2, 3, and 3. So the least common denominator here of 2 and 3 is 6. Excuse me. So what we're going to do is we're going to rewrite everything as a fraction whose denominator is 6. So we have 3 over 2x plus 1/3 is equal to negative 8/3. We want everybody to be a fraction over 6. So we're going to have to be very careful here. This is getting a common denominator. If you multiply the top and bottom by the same value, you will not change the value of the expression. In order to get a 6 in the denominator in our first term, we need to multiply top and bottom by 3. In our second term, top and bottom by 2. And on the other term, on the other side of the equal sign, which seems a little far away now, let me get it a little bit closer. We're going to multiply that by 2 over 2 as well. When we multiply fractions, we multiply straight across top and bottom. This will be 9 over 6x plus 2 over 6 is equal to negative 16 over 6. Also, for those of you that don't recall, this 9/6x can also be rewritten as 9x over 6, because 9 over 6 times x is 9 over 6 times x over 1, which is 9x over 6. So that's the form that we're going to use. Plus 2 over 6 is equal to 16 over 6. That allows us to rewrite this with common denominators as 9x plus 2 over 6 is equal to negative 16 over 6. And the whole idea here is then, if you have two fractions that are equal and their denominators are equal, then it must be that their numerators are equal. So if these are equal, then these are equal, and that allows us to reduce the equation to the following. Or if you like, you can cross multiply, or you can multiply both sides by 6. That's probably a better way to think about that, actually. Let's go back here. Since we have the common denominator of 6, we can multiply both sides by 6 using the multiplicative property for equations, for equality. And what we're going to do is we're going to do 6 over 1 times 9x plus 2 over 6 is equal to 6 over 1 times negative 16 over 6. And what's going to happen is we're going to get some cancellation. And the result is 9x plus 2 is equal to negative 16. And then we can subtract 2 from both sides. Minus 2, minus 2. That is going to give us 9x is equal to negative 18. And then, of course, we can divide both sides by 9. And we get x is equal to negative 2. We should double check that by plugging that answer back into our original equation. If we come back up to this original equation here, we had, let's do a little check. 3 over 2 times negative 2 plus 1/3 is equal to negative 8/3. That's negative 3 plus 1/3 is equal to negative 8/3, which is negative 9/3 plus 1/3 equals negative 8/3. That's true. Check. And we're happy. And that's our answer. The other way to do this alternately, we can get rid of the fractions in the first step, which is usually my personal preference. If I take 3/2x plus 1/3 equals negative 8/3, and we take a look at the denominators here, which are still 2, 3, and 3, and we multiply all terms by the LCD of 2 and 3, which is 6. So I'll take a big old 6 here. And then what we're going to do is distribute right across the entire equation, even across that equal sign. And what we're going to get is the following. 6 times 3/2 x plus 6 times 1/3 is equal to 6 times negative 8/3. And that's going to give us 9x plus 2 is equal to negative 16. And then, of course, we can subtract 2 from both sides. 9x is equal to negative 18. And then we can multiply both sides by 1/9, giving us x is equal to negative 2. So I kind of glossed over some of the steps there, but the whole process is the same. You'll notice that at this stage right here, we were in the same position as the other process up above. Maybe just a little bit quicker, in my opinion. In a similar way that we just dealt with those fractions, we can do the same thing with decimals. In example 3, we have many different decimals here. 0.06x plus 0.05 times 10,000 minus x is equal to 560. What I suggest you do, and it's often kind of what you do when you're solving any kind of puzzle, right? You dump out the box and you count all your pieces and you take stock of what you have. So in this instance, we might first multiply out or distribute to make a mess. That is to say, get rid of the parentheses. Get rid of parentheses. Okay, so we're going to have 0.06x plus 0.05 times 10,000 minus 0.05 times x is equal to 560. So all I did there was I distributed the 0.005. Clean this up a little bit. So this was distribute. Simplify. 0.06x plus, when we multiply by 10,000, that's 4 zeros. We're going to end up moving our decimal 4 spots to the right. So 1, 2, 3, 4. That'll give us 500. And then minus 0.05x is equal to 560. If you want, you can collect like terms right now, or you can get rid of the fractions or the decimals. Let's do that. Let's eliminate the decimals. So what we're going to do is we're going to take this entire equation and we're going to multiply it by 100. So times 100. Why 100? Well, it's 2 decimal places. You'll notice that the majority of our, in fact, all of our decimals have 2 decimal places. Now, another way to think about that is the same idea in the previous example. When you talk about 0.06, you're talking about 6 over 100. And 0.05 is being 5 over 100. So in both cases, you have this LCD of 100, which is why I'm multiplying through by 100, or one value of 10, one factor of 10 for every decimal place you have. So we're going to do 100 times 0.06x plus 100 times 500 minus 100 times 0.05x is equal to 100 times 560. And then we're going to get 6x plus 50,000 minus 5x is equal to 56,000. Then it'll be a simple matter of collecting like terms. Collect like terms. And we have a 6x and a negative 5x. That's going to give us a total of x. And we have x plus 50,000 is equal to 56,000. And then we will isolate the variable. And we'll do that in this instance by subtracting 50,000 from both sides. X is equal to 6,000. And then I guess finally here we can check our work. Let's grab this original equation up here. We'll move this over just a little bit. We'll get rid of x and we'll replace x with this 6,000 and see what happens. Then we have 0.06x plus 0.05 times, oops, I forgot to put the other x in there. Get rid of that x. We'll put 6,000 in there as well. $10,000 minus 6,000 is 4,000. It's supposed to equal 560. Well, 6 times 6 is 36 with 4 zeros, and let's see, this is 6 times 6, and then 1, 2, 3, 4, 1, 2, 3, 4, and we're going to get 360 plus 0.05 times 4,000 is going to give us, oops, 200, and that is equal to 560. Fantastic.